Dear students, here is the assignment for practical soil spectroscopy, and that is building prediction models for soil pH, total nitrogen, potassium and phosphorus content in the soil. Your task would be to build prediction model and evaluate its accuracy for the next soil properties: soil pH, total nitrogen content, potassium and phosphorus content in the soil. Input data for the spectroscopy software Parallels would be TXT files, which you can find on the Moodle, soil cal, soil vial, soil unknowns TXT files. You use 50% of the data for training, the total number of samples is 100, and the remaining half for testing or validation and predictions of unknowns. For other half of the soil data set, we use other 100 samples and usually leave one out cross-validation to estimate prediction error. For model selection, a maximum of 20 factors should be tested. The same situation is what we do on the exercise regarding the total carbon content prediction. Selection of the optimal model is based on the minimum root mean square error of the cross-validation, and this number of model is used for PLSR model calibration or model developing. The data set is the same for you as for total carbon content prediction modeling, but you use these 4 soil properties. Independent data set is consisted of the more than 2,000 spectra in the range from 350 to 2,500 nanometers of visible and near-infrared spectral range. You already have TXT files. Here are the examples for different soil properties for your assignment. First is soil pH. I give you here some screenshots of the process of developing soil pH prediction model. Data manipulation stays the same as PCA for independent data set because you have the same spectral reflectance data, but you build prediction models for different soil properties. Here are examples of PLSR cross-validation for soil pH, building PLSR model, and then if your model is not enough accurate and precise, you can also use bagging PLSR as I explained in the exercise. It is kind of aggregation of the number of PLSR models obtained in the course of resembling it, and it is found to be more robust than PLSR alone and less prone to overfitting. It can improve prediction accuracy. For soil pH, this is an issue. This is an example of the process for prediction total nitrogen content in the soil. For potassium content in the soil, bugging PLSR revealed better results, and for phosphorus content in the soil as well. Remember that data manipulation and PCA here are the same as for total carbon because they are done using the same independent data set or spectral data. At the end, use statistical parameters for prediction model evaluation. Thank you for your attention.